Okay, so today in class, we went over the things we've learned in first semester. We wanted to know what basically do we already know, and what should we know before we start moving on in algebra. The second semester of algebra is going to start getting way more difficult, but these basics from the first semester we have to know. One of the first things we did when you came into this class is you had to know how to add. So you had to be able to do problems like this. 5 plus 3, which is about as easy as it gets. 5 plus 3 is 8. All we did when we came to algebra is we said that we can take 5x plus 3x now, and since these are like terms, just like these are both numbers, we can add them together the same way. 5 plus 3 is 8. Don't mess with the variable, 8x. We can do the same thing even if the variables are different. If they're not just x's, 5x to the third plus 2x to the third is going to give us 5 plus 2 is 7. X to the third, again, we don't mess with the variable or the exponent. We can subtract. You guys know we can subtract. 9 minus 4 is 5. We can do 9x to the second minus 3x to the second, and we'll get 6x to the second. That's all easy work. We could add and subtract before we came into class. What we can't do is this. We're not allowed to say that 12x plus 5 is 17. That is definitely not true. Why not? Because these are not like terms. These aren't like terms. You can't put them together. 12x plus 5x is 12x plus 5x. Okay. Next thing that we learned how to do was we started multiplying. So we took coming from 7th grade, when you had to do something like 6 times 7 is 42. Easy money. Everybody can do that. What we did in algebra is we said, well, we can add variables in there and do the same thing. 6x times 7x is going to be 42. X times x, if you're going to multiply variables at the same base, you add the exponents. These both have exponents of 1. 1 plus 1 is 2, 42x squared. If there's no numbers there, no coefficients rather, we can do x to the 6 times x to the third is x to the 9th. Add the exponents again, not too big a deal. So we can multiply. The big point of this algebra thing is that we could put these two things together, and we could say we can take 2x times x plus 4, and we can actually multiply that. And this is where we came up with all our algebra terms. We called all this adding in algebra. This is combining like terms. Multiplying is multiplying. But when we started multiplying with the adding, put it all together, we start calling this distributing. So what we're going to do is we're going to take the 2x times the x, which is 2x to the second, following the same rules we just saw here. 2 times 1 is 2. And x times x is x squared. And then 2x times 4. 4 times 2 is 8. We have an x, 8x, 2x squared plus 8x. And we're done. More importantly, is we took two binomials, x plus 5, x minus 4, and we can multiply two binomials together, same thing happens. Make sure you multiply everything. X times x is x squared, x times negative 4 is negative 4x, 5 times x is 5x, and 5 times negative 4 is negative 20. Combine like terms, x squared, these are like terms, those are the ones that go together. Negative 4x plus 5x is positive 1x, and then minus 20 we don't have. There's no like terms with the 20, there's no like terms with the x squared. Only these two combine, x squared plus x minus 20, and we're done. So that was the big deal. If we could add and multiply, add, subtract, and multiply, which we said in this class is basically, can you combine like terms and distribute? You could be good to go. The next most important thing we did was we started factoring. And factoring, we're just going to call that undistributing. All we did in factoring is we broke apart any distributing that we saw. So if you had something like this, 3x squared plus 9x, you could divide them both. Well, you see, what do those two things have in common? And we're going to take it out. This is the same thing. This is called, we're factoring out a GCF, a greatest common factor. And we go, okay, what do I see? What do both these have in common? Well, they both have a 3, and they both have an x. So I'm going to pull that out, and I'm going to say, okay, 3x times what gave me all this? Well, we know 3x times something gives you 3x squared, so 3x times x gives you 3x squared. And then we know 3x times whatever goes here is 9x. Well, 3x times 3 is 9x factored. If you want to figure out to make sure that these both are equal, you can multiply this back together and you'll get that. That's all factoring is. We've undone the multiplication. How we did this in a better way, though, is we took, scratch that, x squared plus 9x plus 20. And we said, okay, we can factor this too, but this time we're going to factor into binomials. And we even learned a little trick, and we said, well, if we want to factor this into binomials, basically we've got to find two numbers multiplied to 20 that add to 9. Because we already know whatever goes here, which is x, and whatever goes here, which is x times x is x squared. The numbers that go here and here multiply to 20 and add to 9. So we gave ourselves a little trick to remember this. We said, okay, we can make an x, 20, 9. Here we've got 5, here we got 4. 5 times 4 is 20, 5 plus 4 is 9. So we had to come up with the 5 and the 4. We can do that. Our factored trinomial looks like this, x plus 5, x plus 4. These are our binomials. This is factored. If you multiply this back together, you'd get that. So we got the whole thing factored. We did look at division for a little bit. We do look at division a lot more later in the year, but for now, division is basically this. We can go, okay, we can take 9x to the 5th over 3x to the 4th, and we can divide. 9 divided by 3 is 3. X to the 5th divided by x to the 4th, subtract the exponents x to the 1st. So our answer is just 3x when we divide it. This we're not going to worry about too much. We're really worried. Can we add, subtract, and multiply? That's what algebra is. Can you add, subtract, and multiply? Okay, so we've got the add, subtract, multiply, divide. A couple of the other things that we looked at. We did look at solving equations, but we have to do a lot more of this in the coming days, so we're not really going to worry about this too much right now. We did solve things like this: 3 times x plus 5 minus x equals 4x plus 3. And you could solve that, but how do you solve that? You distribute combine like terms, which are just code words for add, subtract, multiply, and at the very end you use an inverse operation division to figure out the number. But we're not even going to solve that right now because we're going to do enough of that later. The other thing we did is we did graph linear equations. We would graph something that looks like this: y equals 2/3 x plus 7. And we figured out a bunch of tricks to graph this, but since we have to do that anyways in a few days, we're not going to worry about that too much right now either. I will say that slope-intercept form of a line is y equals mx plus b. So in this case, the slope was 2/3, the y-intercept was 7. And that's about all we covered today in terms of review.